What do you think about? Doors. What does a door hinge do? It's what physically opens and closes the door, right? Okay, so the hinge itself makes an angle, right? So the smaller that the angle becomes on the hinge, what's happening between the distance of the door frame and the edge of the door? It's getting smaller, right? And then the larger the angle, the larger it opens, right? Okay, so now envision if I had two doors that were exactly the same, so Mr. Morell's door and my door, and let's say I had this door hinge at, what do you think that is, 45 degrees? And that stayed 45 degrees. Then I went over to his door and opened it 75 degrees. Whose door would be more open? My door or his door? His door, right? So that's the hinge theorem. Kind of makes sense, common sense, right? Okay, now what needs to be true about the hinge theorem is you need to have congruent parts. The congruent parts are my door and his door, hopefully are the same size door. If my door was larger, then it would not work out. And the distance between the door frames, so this would have to also be the same. So you need to have two congruent sides in order for the hinge theorem to work. So please fill in the blank for your hinge theorem here. It's nice and long. It says, if two sides of one triangle are congruent to two sides of another triangle. Congruent.
No, that's how Miss Leonard said it.
Congruent. And the included angle of the first is larger than the included angle of the second. Then the third side of the first is longer than the third side of the second. Okay, so your hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So that's a lot of words. That's a lot of words. Let me show you in a quick diagram. Don't put this in your notes, just watch and soak it all into your brain. Chapter 4, we just talked about congruent triangles. Yes? Yeah. All right. What would make these two triangles congruent? Which theorem? Go back to chapter 4. Not yet. Which theorem? Why would triangle ABC be congruent to triangle DEF? No. You're on the right side. SAS. Good. Side angle side, right? Okay. So then, why then would it be true that AC would be congruent to DF? Andrew's got it. Congruent parts of congruent triangles are congruent, right? Remember doing that? Sure. So if AC is congruent to DF, then what's true about the lengths? They're also going to be equal, right? So last chapter we were talking about congruent triangles having congruent parts, which means that the lengths would also be the same. Well, what if I change this triangle to no longer have the included angle being 30 degrees, and I changed it, let's go to 40 degrees for DEF. Now, is AC equal to DF anymore? No. Which one's going to be larger?
DF.
DF. That's the hinge theorem. As simple as that. So don't make it any more complicated than it is. So if we look at the actual example that's below here, we're going to fill in the blank. I have congruent parts, so that's good. Now we're looking at the included angle. Which one's a larger number, 86 or 35? 86, so if I go opposite of the 86, WX would then also need to be larger than the length of RT. Okay. All right, next one. Do we have two congruent sides? Yes, we've got this and this. We've got the reflexive property. So now let's look at the actual side lengths. Which one's the larger number? 24 is definitely larger than 23. So I'm going to label it 1 and 2 to make life easy first. So which is going to be the larger angle? Angle 1 or angle 2? Angle 1 is going to be larger because it's opposite the larger side. So that's angle PST. So angle PST is going to be greater than the measure of angle SPR. Hinge theorem.
So, because 24 is bigger, it's the one that's in that triangle.
Right. Yes. And I know it's not drawn because it looks like a parallelogram, but don't assume it's congruent because it looks like they're congruent. Okay? All right. And then the last example, we have Pat and Andy. I'm very proud of this diagram that I made.
That's good.
It's a pretty good diagram. So what we have, it says Pat and Andy go on a hike. Pat hikes 5 miles. Where is he going? West. Turns 45 degrees south, and then hikes another 3 miles. Andy hikes 5 miles east, turns 65 degrees north, and then hikes another 3 miles. Who is closest to camp?
Pat.
They're not the same. Me. Pat? How many think Pat's closest to camp?
Me.
How many thinks Andy's closest to camp?
Oh, come on. Just because I'm fat doesn't mean I'm
All right. Let's see who actually is right. What's the interior angle of this triangle going to be? 135? What's the interior angle of this triangle going to be? 115? So who is really closer?
Andy.
Andy is closest.
Little Andy.
Yep, you gotta find that interior angle. Okay? All right, so let's just fly through these practice problems. Tell me if I'm going too fast. Which is larger, ST or VW? ST. Does everybody see why ST is larger? Because it's opposite the larger angle? Yes? Nods of heads? I can slow down if I need to. These are just practice problems. We're done with the notes. DE or EF, which is larger? EF. So I would say DE is less than EF. Yes? Okay. JKLM, which is larger? Which would be larger, JK or LM? LM. LM's opposite the larger angle. So LM would be larger. So JK would be less than. Angle 1 or angle 2, which is larger? 1. So the measure of angle 1 would be greater than angle 2. Which one's larger, 1 or 2? 2. So the measure of angle 1 would be less than. 1 or 2, which is larger? 1 is opposite the 30. So the measure of angle 1 is greater than the measure of angle 2. 1 or 2, which is larger? Yeah, now don't get thrown off by the 18s. That's just meaning that we have our other set of congruent parts. So go opposite of the 17, go opposite of the 16. 17 is larger than 16, so 1 would be greater than 2, right? Yeah, hopefully. All right, how about this one? So AB, why are they going to be equal?
Both a 9.
They're not both 9. So AB is here. The angle opposite of AB is there. The angle opposite of CD is there. Why are those two angles congruent? They're vertical angles. Vertical angles are congruent, right? So those would be equal. All right, let's throw some algebra into our life. Yeah, why not? So I'm going to label 1 and 2 first. Is angle 1 or angle 2 the larger angle? Angle 1, right? So angle 1 is larger than angle 2. Well, what is the measure of angle 1? 52 degrees. So now I have 52 degrees is greater than, what's the measure of angle 2? X plus 18 degrees. How do you solve that? Subtract 18 from both sides, which gets us 34 is greater than X, or X is less than 34. right? Just flipping it around. X is less than 34, right? That's, yeah? Okay. All right, last one. Now we have 126 degrees for my angle and 21 degrees for my angle. Which is going to be the larger side, x or 3x minus 8?
I think 3x minus 8.
Yes, that's a little obvious. So 3x minus 8 is larger than x. How do you solve that inequality?
So, ooh, I don't know.
Subtract 3x from both sides. Negative 8 is greater than negative 2x. What do you do next? Divide by negative 2. What do you do to your sign when you divide by negative? Flip it. So x is greater than 4. Okay? All right, that is that.